Hey, Algebra 2 friends, here we are in section 12.6, statistical measures. So our vocabulary, some of which is going to be familiar, will be really useful. Even if you are going to college and you end up taking like a psychology course, oftentimes there's this little opportunity for you to take some kind of statistics. You just need it for data collection and stuff like that. So make sure you keep abreast of these terms. Measure of central tendency. These are words that you are familiar with. Usually the measures of central tendency would be the mean, and we know that means the average, the median, just like on a road, that's the middle, and the mode, we usually think of most. And now for the measure of variation, the measure of variation really could be referred to as dispersion, and that usually refers to, in a way, how scattered the data is that you're using. So one measure of dispersion would be like the range, right? Another would be the variance that we're going to talk about here. So that would be a measure of dispersion. And also, in some way, we can talk about the standard deviation as it relates to variance. So we'll discuss that. So the discussion of variance and also standard deviation are going to be related to just how different or how far spread out the data is from the mean. And so the symbol that we use for variance is going to look kind of like this. It's actually a lowercase sigma notation, and there's a whole calculation for this little symbol, and I'm going to show you what that is here. So this symbol is not variance. This is actually standard deviation, where variance is going to be what's underneath the radical. So let me show you what variance looks like. So variance is sigma squared, and that's going to be x of 1 minus x with a bar at the top. That means the average of the data. We're going to square that, and we're going to keep subtracting or finding the difference between each item, each data item, and the actual mean. And then what we'll do once we get to x of n, then we're done with that portion, and then we're going to divide all of that by the number of terms. That's the variance, and therefore, maybe it's not like logical, but the standard deviation is going to be just sigma, where we take this whole thing, let me just make a copy of it instead of rewriting. We take this whole thing and we're going to take the square root of that. And so by that we get the standard deviation. So the standard deviation will have a little bit more of an effect, or a little bit more, it'll feel more relevant when we reach next chapters. But here's just the gist of what we're going to cover today. So even though we know what the measures of tendency are, the measures of tendency being mean, median, and mode, even though we know what they are, the question is, when do we choose to use one over the other? And this little handy guide I thought was really good, so I wanted to show you all. When the data is spread out and you want to get an average of the values, that's when you're going to use the mean to kind of get an idea, a general sense of what's going on. With the median, you use this when the data contains an outlier. So like if we were talking about the average age of students in a particular class, and you know that in that class there's this little young genius who is 4 years old or something and taking those high school classes. Well, that 4-year-old, that outlier, that person who is far away from the vast number of, 14, 15, 16, 17, 18-year-olds that are in your class, that person's going to really skew your data, and it's not going to give you a good sense of the students in the class. So you would rather use median in this case when you have outliers. The other one is the mode. We use the mode when the data is tightly clustered around one or two values. So we can say, all right, for the most part, the most number that we see in this situation would be whatever the number is, or whatever that data value is. Here in example 1, we are given the opportunity to choose a measure of central tendency that would best fit the situation. So a sweepstakes offers a first prize win of $10,000, 2 second place prizes of $100, and 100 third place prizes of $10. Which measure of central tendency best represents the available prizes? And so if you're thinking about what is most available, most abundant, in this case, it would be clear that you should probably use the mode, right? Because the mode would show us which one is most available, which is the most. And if we're considering the mode, obviously it would be the $10 prizes. Not 10%, but the $10 prizes, my bad. The next part of this is which measure of central tendency would the organizer of the sweepstakes be most likely to use in their advertising? I don't know. I kind of think that this is, depending on how you would spin it, but it could be anything. Your text suggests that, and I could see the logic behind it, suggests that the organizers might use the mean and say you can win over $100 if you took the average of each of the different prizes. You can, calculate it that way. I still think that's a little disingenuous. So they calculate that you'd have about $109 to brag about. Winners, on average, win $109, depending on the number of people that they have and all. So that's how one might use the measures of central tendency. So we talked about standard deviation in our introduction where we discussed the vocabulary. Here's a more formalized or a neater looking way of writing it down. And we're going to use that in this next example. So here in example 2, we're going to talk about the standard deviation of a set of data. The table shows the population in millions of 11 eastern states as of the 2000 census. Find the variance and standard deviation of the data to the nearest 10. So the first thing we need to do is figure out what are the steps to finding variance and, of course, the standard deviation. So the first step is to indeed find the mean of the data, and we know how to do that. We're going to take all of the data items added up and divide by the number of numbers we have here. And so we have 11 data points, and we're going to add those up. So once we've added those up, and then when we divide by 11, we get about 5.418, and that part is repeating. So we'll say that's about 5.4 people would be the average. The next step, or step 2, is to find the variance, which we knew is lowercase sigma squared. And so to find that, remember, we're going to find the difference between each term and the average, right? The difference between the mean and the number, and then square those, find all of those, and then we're going to divide by the number of numbers. And when we do that, and I know this is a little bit much doing it by hand, we'll explore and see if we can find some ways that technology can help us. When we do that, we take 19 and we would subtract the average, which is 5.4. We're going to take that quantity, square it, and then we're going to add to that the next one. And you see what we're going to do. We're going to go 12.3 minus 5.4, which is the average, square it, and we'll continue adding those. And when we finally calculate that, we end up with something like 344.4 over 11, which is approximately 31.3. So this is, so what we did in step 2 was actually find the variance, and now we're going to find the standard deviation, which is just a sigma, and it's going to be the square root of 31.3. So that's going to be approximately 5.59. And how does this all work out? What does this have to do with anything? Which is a great question. What the standard deviation does is it gives us, that's not going to work because I don't have the space. Let me try again. Let me zoom in a little bit. What the standard deviation is going to do is give us an idea of where the data falls. So there's something that we're going to talk about soon called the normal curve. And within the normal curve, this is the way most data, when randomly chosen, will fall. Here, this would be the mean or the average. What you're going to find is that standard deviation represents the distance from here to here, and there's going to be several standard deviations that we could measure from the mean here. The standard deviation represents um, this spacing, and we have formulas about, or ideas about, we'll discuss it soon, how much of the data will fall in one of these portions or standard deviations of the curve. I know it sounds like a whole bunch of gobbledygook, but it'll make sense, I promise, by the time we get through the next section rather. Guys, please let me know if there's any questions, and I look forward to talking to you all soon. Take care.